So first things first, what exactly is data science? So you must have heard the term a lot, as it's one of the biggest buzzword in the tech industry and beyond. But let's break it down. So as it as its core, data science is an interdisciplinary field. So this just does not mean that it's just not one single subject, but it's a blend of many. So it utilizes scientific methods, processes, algorithms, and systems to extract knowledge and even the insights from various forms of data. Whether they that whether that data is structured or not, but like structured data are in a spreadsheet, or unstructured data like text in an email or images on a website, but the primary goal remains the same. So the primary goal of data science is to analyze all the data to gain deep insights and, most importantly, to inform and improve decision making. So you can think of a data scientist as a modern day detective, shifting through clues the data to solve more complex problems. And as you know that it combines skills from statistics, computer science, and domain expertise to tackle complex problems. So as you can see in the diagram, so what and all is done. So in mathematics and statistics, linear algebra, calculus, data visualization, inferential statistics, predictive modeling, a lot of things are there. And even in the programming, algorithms is there, data management is there, feature engineering is there, big data is there. And in the sciences, you can see the domain applications that would include economics and finance, public policy, technology, languages, medicines and health sciences, humanities, and social studies as well. So, what is machine learning? So, machine learning or ML is a subset of AI, that is artificial intelligence. While AI is the broader concept of machines being able to carry out tasks in a smart way, machine learning is the specific application of AI that enables system to automatically learn from the data and improve their performance over time, just without being explicitly programmed for every single task. For example, instead of writing code with thousands if and then rules to identify a cat in photo, you train a machine learning model by showing it thousands of cat photos. So it learns the patterns on its own. And as you can see, the machine learning can be categorized into three forms, that would be supervised, unsupervised, and reinforcement learning techniques. Now we'll see the importance of data science as we had. So basically, what skills do you need to be this detective? As we know, data science combines skills from three main areas, that would be statistics, computer science, and domain expertise. So you need the statistical knowledge to analyze and interpret the data. So that remains the prominent thing that needs to be kept in mind, as domain expertise is also one of the major thing that is required to make any sort of project or something. And as we know that the main agenda over here is to analyze and interpret data. So the computer science skills to manage as well and process large data sets and build models. And even the domain expertise, that means knowledge of a specific field like healthcare or finance, that could be to understand the context of data and to basically ask the right questions as well. So that remains there. And as we know that the insights derived from the data science can also drive statistic initiatives and enhance competitive advantage as well. and it also enables business to understand the customer behavior and market trends through data analysis. So, okay, data science process, as you can see. So, this diagram basically provides a great visualization of breakdown what just we discussed right now. So, as you can see, it's a cycle that mirrors the scientific method that would include observe, question, hypothesize, and experiment, then analyze, and then conclude. So, over here in the computer science slice, that means so as we have tools for handling data. This includes programming, algorithms, databases, data processing, and working with big data. Then we will have mathematics and statistics as well. So, this is the foundation for making sense of the data. It involves concepts like linear algebra, calculus, probability theory, and more descriptive and inferential statistics. So, this is how we move from raw numbers to predictive modeling. And finally, the third slice is the domain application. So, this is the context. Whether you're working in medicine, finance, or any other like industry, you can say technology as well. So, you need to understand that the specific field to apply the data science like insights effectively, as we know that data science lives at the intersection of this all these areas. So it is the complete package for turning the data into action. So as you can see, there are types of data that would include unstructured data, semi-structured data, and structured data. So as we know that structured data is highly organized and that would be easily searchable, such as data in relational databases. Unstructured data would be like images, text that basically lacks a predefined format and requires more complex processing techniques. And semi-structured data would be like something like CSV files that is there that is separated by commas, or JSON files, XML files, or MongoDB files could be categorized into semi-structured. So whether it is not properly structured and it is not lying in the category of unstructured structured as well. So it is lying in somewhere between both of them. So that is what semi-structured data would look like. So the key tools in data science would be like, as we are aware that Python is also an essential. R is there, SQL is there, Java, Apache Spark, TensorFlow, Git is there. So this all are very much important to learn. And as we know, the data visualization tools such as Tableau and Matplotlib that basically help communicate insights effectively, because they help us to portray the data. And the common tools used in data science that include programming languages like Python and R for data manipulations and analysis. And big data technologies like Hadoop and Spark are essential for processing large data sets effectively. So, introduction to data visualization. So, data visualization is the graphical representation of information in data. So that would just be like basically portraying the complex data in a way, in a such a way that anybody can understand. So it is just making the complex data more accessible. So a person who is not aware of the coding part or something, so they can like basically interpret what is being done over here in that. So that is why we are using the visualization part. So it is basically done to portray the insights to a non-tech user in an effective way, so they can also understand what and all the thing is going on, and what and all the data is being showed over there. So, and the effective visualization also helps us uncover trends, patterns, and outlets that may not be apparent in raw data. So, outlets may be like some blockers and all, some mistakes could be there. So that really is helpful to identify and by doing visualization, because sometimes in the raw data we could not identify it, but through data visualization we can overcome this as well. And as you can see, there are lots of types of charts that can be used for data visualization. So this all visualization depends upon the data that you are going to portray. So it depends upon the metrics as well that you want to visualize. So it depends upon how you want to curate the dashboard and how effective it is. So that remains one of the top priority, because data visualization is very much important. So this now we'll see about supervised learning. So basically in supervised learning we train a model using label data. So this means, just wait a second. Yes. So in supervised learning, we train a model using label data. So this means that for every piece of input data, we already know that the correct input or a label. For example, if we are building a spam detector, our training data would be a large set of emails where each one of is already labeled as either spam or not spam. So the model learns the relationship between the input, that would be the email text, and the output would be the label. So common algorithm used for this linear regression for predicting continuous values would be like a house price and decision trees or support vectors machines for classifications tasks like spam detection. So this approach is incredibly common and is used in a huge number of applications. From the spam detection, as we mentioned, in the medical diagnosis system. So in short, like supervised learning involves a training that is basically based on the label data, where each input comes with a corresponding output. And for this, common algorithms that would include linear regression, decision trees, and support vector machines. And this approach is widely used in applications like spam detection and medical diagnosis. And as I have mentioned that like if we are building a spam detector, then our training data would be a large set of emails. So where each one is already labeled as like either spam or not spam. So the model learns the relationship between the email, that means the email text, and the output, that means the label. So the common algorithms used for this would include linear regression, as I've mentioned in the slide. So that is used for basically to predict continuous values, and decision trees or support vector machines for classification like spam detection. So as I've told that decision trees or support vector machines are used for spam detection, but Linear regression is used for predicting continuous values like house value, house price and stuff. Then this approach is incredibly common, and it is used in a huge number of applications, from the spam detection, as we mentioned, to the medical diagnosis team as well. So when medical diagnosis can be also there. So now we'll see unsupervised learning. So unsupervised learning deals with the data that does not have labels, that basically focus on finding hidden patterns or intrinsic structures. Like as you can see in the diagram, the unlabeled data is there, then the interpretation is done, then some sort of algorithm is applied, then the processing is done, then finally the outcome is given. So it basically is something like unsupervised learning is a type of machine learning where the algorithm learns from the unlabeled data without any predefined outputs or target variables. As you can see in the diagram, that means that the input raw data is unlabeled. Nothing is labeled. Then it goes to the process of interpretation. Then an algorithm is applied. Hence, after that, the process is done, then the outcome is there, then it becomes a labeled data, so it processes on unlabeled data, and it is done by the techniques like clustering and dimensionality reduction are frequently employed in this category. And unsupervised learning also works with the data that does not have any labels, as I've mentioned, because they are unlabeled data. So the goal over here is just not to predict a known output, but rather to find hidden patterns or the intrinsic structure within the data itself. So the diagram here shows a great example. So as you can see, we feed the algorithm a bunch of unlabeled images of vegetables, and it learns to group them into clusters that would be onions, peppers, eggplants, so based upon their visual similarities, so without ever being told what those vegetables are. So the most common techniques used here are clustering for grouping similar data points together, and dimensionality reduction for simplifying complex data. So this is extremely useful for applications like customer segmentation, where you find, like, not find, where you want to, find the natural groupings of customers for marketing, or for anomaly detection in cybersecurity to find unusual network activity. So that all is there for unsupervised learning. So now we'll see reinforcement learning. So reinforcement learning is a type of machine learning where an agent learns to make decision by taking actions in an environment to maximize cumulative reward. So it is basically used in robotics, game playing, and autonomous system. So the agent learns from the consequence of its actions and adjusting its strategy based on success and failure. As we have discussed unsupervised learning and supervised learning, so this is a bit different from the other two, and it is modeled on how humans and animals learn. So we'll like see like how reinforcement learning is about training an agent to make a sequence of decision. So over here the agent learns by taking actions within the environment to maximize some notion of cumulative reward. So you can think of training a dog. So when it does the right thing, you give it a treat, like, right? So that would be a reward. And when the dog does the wrong thing, it gets no reward. So over the time, the dog learns which actions lead to a reward. Therefore, that's how an RL agent learns in the same way. So through that is basically the main principle over here is trial and error. So it learns from the consequence of its action, then constantly adjusting its strategy to get better. So this type of learning is the magic behind self-driving cars, advanced robotics, AI. So that can basically master complex games like chess or Go. That could be also there. So over here, when the dog does the right things, it gets a reward. But in RL, when so giving the example of the same thing that it would be a dog. So when the dog does the right thing, it gets an award. Like that would be sorry, not award. That would be reward. But when the dog does the wrong thing, so it will get a penalty. So in RL also there is a penalty when the model does the wrong thing. So that time they will be getting a penalty, and that would be depend. Basically, that is dependent on like how it is being done. So that is there, and it is calculated in negative. So we'll discuss about this in depth in future. So now we'll see the challenges in data sciences. So as we can see that while data science and ML are incredibly powerful, but it's not always a smooth road as well. So there are more significant challenges in the field that the practitioners have to navigate. So as we can see, the one major challenge in data science is the data quality. So if the data quality is poor, then it can lead to incorrect conclusions. And there remains the ethical considerations that would include data privacy, biases, and algorithms. That is very much crucial for responsible data use. The rapid evolving field requires continuous learning as well. So the adaptation of new technologies and methodologies as well, as you can see, and the infinite number of data sources is also there. Business problems are not clearly identified, difficulty in order to find the skilled data scientists as well, and of course selecting the right tool, because it is also a pivotal role that plays, because you need to have the right tool to portray the data in an efficient way. Lack of security is also there, lack of business growth is there, a proper method to get a value of data science is also there. So these are the major challenges and most important challenges of data science. But as far as of a data quality, so one of the biggest and most common challenges is data qualities. So there is a saying, garbage in, garbage out. So if your data is incomplete, inaccurate, or inconsistent, any conclusion you draw from it will be flawed. So a huge amount of data scientist time is spent is just cleaning and preparing the data to make sure that the data is reliable. So data quality is the prominent factor that matters the most to data scientists. As for ethical considerations, so this is a huge topic. So we have to be very careful with data privacy, ensuring that the personal information is protected as well. There's also major issue of bias in algorithms as well. So if a model is trained on a biased data, then of course it will produce bias and unfair outcomes. For example, a higher algorithm trained on historical data from a male dominated industry might unfairly penalize female candidates. So ensuring fairness and responsibility in data science is absolutely critical, because it can lead to a blunder. So that's why ethical considerations also remain on top. So we have to be very much careful regarding this. And as we can see, the evolving field. So finally, as we know, data science is rapidly evolving field. So new technologies, methodologies are emerging all the time. So this means that to stay relevant and effective, right? So you must be committed to continuous learning and adaptation. So the bubble chart over here also points out the other challenges, like data security is also mentioned over here, difficulty finding skilled talent, clearly identifying business problems to solve as well. So these are the major challenges that are being faced in data science. So where is all of this leading? So the future of data science and machine learning is incredibly bright and full of potential. So the few, as we can see, we are going to see continue advancement in AI, that is more automation of data science tasks and even powerful predictive analytics. So one of the key emerging trends is the rise of explainable AI, that is XAI. So this is a moment to create models that just are not accurate but also transparent so that we can understand why they make the decisions that they do. We'll also see the further integration of AI into our everyday applications, making them smarter and more personalized. So as we can see, as organizations continue to realize the power of the data, so the demand for skilled data scientists is only going to grow. So this Venn diagram, as you can see, neatly shows how all of these fields, that would be AI, machine learning, deep learning, big data, and data science, are related and interconnected. So expertise in these areas will always continue to be highly valuable. So as you can see in this conclusion, like basically data science and machine learning are fundamentally transforming industries across the globe by enabling smarter and data driven decision making. So from healthcare and finance to retail and technology, embracing these data driven approaches can lead to significant advancement. And embracing data driven So, embracing data driven approaches can also lead to significant advancements in various sectors that would include healthcare, finance, and technology as well. For any of you, they are looking to enter this exciting field. So, you basically need to develop a solid understanding of the core concepts, that would be the key tools and the essential techniques that we have discussed. So they are the most important things that needs to be kept in mind while doing it. So this will be the introduction part that we'll be going through. So any questions regarding this? So this will be a just brief overview and like introduction part basically. So what data science is. So we will be covering the topics in depth going forward, and as there will be projects that will be assigned to you soon. So we'll be working upon that. So any questions regarding
Ma'am,
any? Yes.
ma'am, would you please provide note of this lecture?
Yes.
Okay, ma'am. Thank you.
Okay.
What tools and technologies will I be using in this internship?
Sorry.
What tools and technologies will I be using to like train the model?
Your voice is not audible. Can you repeat once again? Your mic is disturbing, I think. What tools and
Like what tools or technologies are used in data science?
So, as I've told, data visualization is also a core part of it because through that we can visualize. And for programming languages, we'll be using Python, R because they are used for data manipulation. For database querying, we can use SQL. And big data is also used. For machine learning and deep learning frameworks, TensorFlow is highlighted because it's an important tool in data science. And libraries would be skitlearn, scitosh will be there. And big data technologies would be Apache Spark, Hadoop. But as we have discussed, this presentation also specifically mentions that Apache Spark is also used. So these will be the technologies that will be using to make.
And also, I want to know like the classes or like how would it work?
How will it work in what sense?
Like you will be giving us the projects, or how would we learning or working? How would that fit?
So basically, there will be sessions. So based on the topics, so upon that we'll be working according to the project wise. So basic understanding of the topics will be given over there. So how the project might look and how it is supposed to be done, how it is done, the methodologies and stuff that will be explained.
Like on a Google Meet meeting,
Yes. So you guys have not received the that PDF has not been received yet.
which PDF?
Okay, so it has not been shared yet. So shortly you'll be getting the PDF where you guys will be assigned the projects and everything. So after that, I think you will be having no doubt.
Okay, ma'am, thank you.
Yeah. So apart from this, there is no questions. So there are no questions. Then we'll end the session.
Hello,
Yes,
am I audible? Hello,
not properly.
am I audible, ma'am?
Yes, please.
Yeah, can you tell me which algorithm is mostly commonly used in the real projects of data
So
science and
yes, there
machine
are lots
learning?
of algorithms that will be used. So it depends upon the project that you will be doing. So for classification, different algorithm is used.
Ma'am,
Regression.
I have all over which algorithm is mostly used in data science and machine learning? Mostly.
So linear regression is also used. Classification is used.
Hello, ma'am.
Yes.
When projects will be assigned?
I think soon you will be getting the project's PDF as well, and I think it will be done soon. I'm not sure like on which day, but it will be done soon.
Okay.
Yeah.
Hello, ma'am. Am I audible?
Yes.
So I wanted to ask that what type of project we are getting, and if we are getting like proper end-to-end deployed projects.
So that will be given by the support team as well, because I am not sure what kind of projects you guys will be getting now. So the syllabus keeps on changing with time.
Hmm.
So
Okay, ma'am.
that,
Thank you.
yeah, so that will be intimidated by the support team as well. And after you get the PDF, you will be having a brief idea. So any more questions? Any more questions? No more questions, then I
Ma'am,
think,
ma'am,
yes.
I have a question. This is not related what we have stated till now, but are there any resources you suggest us to go deeper in this data science and machine learning, like videos or material like that?
Yes, like there are lots of channels and everything is there. So I don't have anything particular to say you right now, but I'll get back to you regarding this in the next session. So you want a particular like video kind of session, right? So
Yeah,
that
ma'am, because you have a good experience, so you have a good knowledge about that. There are a lot of channels in YouTube or in Google like that in browsers, but we can't clarify the distinguish between them, right?
yes, yes,
So,
I get
yeah,
it.
that's why I am telling you.
Okay, so I'll get back to you regarding this. I will make sure that I find a good one and I'll get back to you regarding this.
Ma'am, I hope you will remember this.
Yes, yes, I will remember, Umar.
Thank you.
Yeah. So that's it. No more questions. If you guys have any questions, then please feel free to ask. No more questions.
So, ma'am, will the classwork be every day? Like, we have also a project works. Will be aside session for them and another session for this what we are learning or studying here? You teach us, right? So, will it
Yes.
continue or and also have a different session for this project work?
No, basically what will be done is like it will be taught how the project needs to be done. So a sample pages and like we'll show live interaction labs as well. So there you will get an idea like how the project needs to be made. So that's how we'll be proceeding forward. And as for projects, so they like the sessions are itself for project itself, right? So there will be no dedicated sessions separately for projects, but we will be doing in-house training in those sessions as well. So those sessions are dedicated for the project itself. So we'll be
Okay.
proceeding in that way. And as for projects, you need to simultaneously balance them and you need to do it. So there will be like no separate time for that. So you need to learn and then you need to do it simultaneously.
Okay, ma'am.
Yeah.
When will be the next session?
That will be informed by the support team. I am also not sure about that. So those all intimations will be given by the support team itself.
Okay, thank you.
Yeah. Okay, then if there are no more questions, then we'll wrap up the session. Okay.